Okay guys, what we're going to look at today are what we call recurring decimals, and most of you would have seen this before. Recurring decimals are, for example, when we write 1/3 as a decimal, and we know that's the same as 0.33333, and these threes go on forever. Okay, now we show this by writing it either as 0.3 with a bar above it, or as 0.3 with a dot above it. This is the way that we show this. Okay, that bar and that dot just means that they go on forever. Okay, we also have numbers like 2/3, which we know is 0.66666 on forever. Okay, and we show this one as 0.6 with a bar above it, or 0.6 with the dot above it. And both of these just mean recurring. Okay? Now, sometimes you'll see numbers where not just one number recurs, but multiple numbers do. Okay? So for example, if we do 2 out of 11, okay? And if you type that in on your calculator, you will get 0.181818, and that goes on forever. Okay, now we write that one as 0.18, and the bar covers both of them, or 0.18 with the dots above both of them. Okay, you'll also get sometimes there'll be a recurring number like 0.345, and that goes on forever. Okay, and we write this in the same way, so it's equal to 0.345, and in this case the bar goes across all three numbers. That means those three numbers repeat. Okay, or 0.345, and we put the dot above the first and the last number in the sequence. Okay, so these are recurring numbers. That's the first part of the lesson. The second part is teaching you guys how we turn these into a fraction. Okay, so we already talked about 1/3, 2/3, 2/11. Okay, let's have a look at, let's say, well, firstly, we know 1/3 is 1/3. So let's try that one. So if we have 0.33333 going on forever, or 0.3 reoccurring, and we want to write this as a fraction. Okay, so writing this one as a fraction. There's a really nice trick to doing this, and this works with all recurring decimals. Okay, so what we do is we say, let A equal 0.33333, okay, going on forever. Okay, then we're going to say let 10A equal, and all we have to do then is multiply this by 10. So then we have 3.33333, and this goes on forever. All right, these are our two equations that we have now. Okay, so we have A equals 0.33333, and 10A equals 3.33333. What we're going to do is we're going to put A again underneath the 10A. Okay, because this is going to be more useful to us. And then looking just at this part here, this is going to be what we're going to work with in order to work this out. So we're only looking at this bottom part here, ignore that top bit. Okay, we are going to now subtract these. Okay, so we're going to do the top one minus the bottom one. So if you have 10A minus A, what do we have? Well, we have 9A. So there's going to be 9A's here is equal to. Now, what you can see here is that we have 0.33333 going on forever here. And we also have that here. So if you minus those from each other, they're going to go away. Okay, so if you minus the 3 reoccurring from the top, it's going to be gone. Okay, then we also have 3 minus 0. So what we end up with is a nice 3 here. Okay, so those three recurrings cancel out, and then you just get 3 minus 0. All right, so we get 9A equals 3. And now we can just use algebra to work it out. Okay, so divide both sides by 9. Okay, 9a divided by 9 gives us a, and 3 divided by 9 gives us 1/3. So we can say here that we have a is equal to 1/3, and a was, back at the beginning, a was 0.3 recurring. Okay, so we're going to look at this again because that's the first time doing it. Maybe it's a little bit confusing for you. So let's try it again with another one. Okay, let's do 0. So let a equal 0.7 recurring. Okay, so that's what we're going to say. So we have 10a equals 7.777777 going on, and a equals 0.777777 going on. Okay, now again we can subtract them. Okay, all those crazy 7s are going to cancel out, so we just get 7 minus 0, which is 7, and 10a minus a is 9a. Okay, so 9a equals 7. We can divide both sides by 9, and we just get a is equal to 7/9, and we now have a fraction. Okay, nice and easy. Let's try one that's a little bit harder. So we'll do one that I know is going to work. So we'll go, well, they all work, but we'll do one that I know the answer for. So, oops. We will try 0.363636 going on. Okay, so now in this case, if we times it by 10, we're going to get 3.63636. Okay, and that's not super useful because we want both the 3 and the 6 out the front. We need both of them. We need both our recurring decimals to be in front of the decimal point. So we're going to say let 100a equal 36.36366 going on. Okay, and our normal a was 0.363636. Okay, and again, if we minus them, okay, 100a minus a gives us 99a. 36 minus 0 is 36, and all of those 3's and 6's cancel out. Okay, which is really nice because now we just divide by 99 on both sides, and this one's going to take some simplifying. So a is equal to 36/99. Now we can divide all of these numbers by 3. So 36 divided by 3 gives us 12, and 99 divided by 3 gives us 33. Okay, we can see that still can be simplified further because both of these can be divided by 3. So 12 divided by 3 is 4, and 33 divided by 3 is 11. And there we have our final answer. Okay, so we can do this with any numbers. Let's try another one. We said one way back up here. We talked about 0.345 recurring. So let's try that one. So we're going 0.345 recurring. Okay, so we know that a is going to be 0.345 going on forever. Now this time, for all of those decimals to come to the front, and the reason we need that is because if we, let's say that we did 10a, I'm going to show you, if we make it 10a, we get 3.453453, and you can see that if we try and subtract this one and this one, they're not going to cancel out. Okay, so it's not going to work. So this first option is not going to happen here. Okay, so 10a is not going to work. We need the 3, 4, and the 5 to be in front of the decimal point so that the first number after is a 3. So for that to happen, this time we're going to need to multiply by 1000. So we have 1000 1000A is equal to 345.345. Okay, and again we minus them. Okay, 1000A minus A gives us 999A is equal to 345 minus 0, so 345. Okay, A is equal to 345 over 999. And now for this one, I'm going to use a calculator to see if it simplifies. 345 over 999 gives me 115 over 333. Okay, so again we had to divide by 3, and that's it. All right, let's try one a little bit harder. Let's make it 1.2 reoccurring. Okay, so this means 1.22222. Okay, all right, so with this one we're going to say again, we only need one of the 2's to be in front of the decimal point, so we're going to say let 10A equal 12.2222, blah, blah, blah. Okay, A was equal to 1.2222 and ongoing. All right, and when we minus them, we get 10A minus A, which is 9A, is equal to 12 minus 1 is 11. Okay, so we can divide both sides by 9. 9A divided by 9 is A, equals 11 over 9, so we have 1 and 2 9s. Okay, and that's it. This is how we turn recurring decimals into fractions.